it is permissible to run branch circuits from the new panel through the existing panel, known as a feed-through or add-on panel configuration. However, splicing of branch circuit wires is not permitted within the panel itself. Splices can be made outside the panel in junction boxes or with approved connectors within conduit bodies. When implementing a feed-through panel configuration, several guidelines must be followed. Firstly, the existing panel must be rated for the combined amperage of the circuits from both panels. This is a critical safety consideration to prevent overloading the panel. Secondly, the circuit breakers in the new panel must be properly sized for the branch circuit wires they are protecting. Overcurrent protection is essential to prevent damage to the wiring and potential fire hazards. Thirdly, the conduits feeding the old panel must have sufficient capacity for the additional branch circuit wires. Overfilling conduits can lead to overheating and insulation damage. The wires should be supported and bundled securely within the old panel. Proper wire management ensures that the panel remains organized and safe. The new panel should be connected to the existing panel through a circuit breaker or fusible switch. This provides a means of disconnecting the new panel for maintenance or in case of a fault. The old panel should be labeled to indicate that it contains feed-through circuits. This helps future electricians identify the configuration and avoid confusion. Additional considerations include ensuring that the new panel is installed in a convenient and accessible location. This makes it easier to perform maintenance and repairs. Consider using a panel board that can accommodate future expansion if necessary. This can save time and money in the long run. Obtain necessary building permits and inspections before performing any electrical work. This ensures that the installation complies with local codes and regulations. The electrical codes are designed to ensure the safety of electrical installations. These codes are updated regularly to reflect changes in technology and best practices. Compliance with electrical codes is mandatory for all electrical work. Failure to comply with electrical codes can result in fines, penalties, and even legal action. Building permits are required for most electrical work. Building permits ensure that the work is inspected by a qualified electrical inspector. Electrical inspectors are responsible for ensuring that electrical installations comply with the electrical code. Electrical inspections are an important part of ensuring the safety of electrical installations. Before starting any electrical work, it is important to obtain the necessary permits and inspections. The electrical code is a complex document that can be difficult to understand. If you are not familiar with the electrical code, it is important to consult with a qualified electrician. A qualified electrician can help you ensure that your electrical work is done safely and in compliance with the electrical code. Electrical work is dangerous and should only be performed by qualified individuals. If you are not qualified to perform electrical work, it is important to hire a qualified electrician. A qualified electrician has the training and experience necessary to perform electrical work safely and in compliance with the electrical code. When working with electricity, it is important to take precautions to protect yourself from electrical shock. Always turn off the power to the circuit before working on it. Use insulated tools and wear rubber gloves and shoes. Never work on electrical equipment in wet conditions. If you are not sure how to work safely with electricity, it is important to consult with a qualified electrician. Splicing wires within an electrical panel is generally not permitted because it can create a point of weakness in the circuit. These splices can become loose over time, leading to arcing, overheating, and potentially electrical fires. Electrical panels are designed to provide a safe and organized way to distribute electricity throughout a building. They are not intended to be used as junction boxes for splicing wires. All connections within an electrical panel should be made using approved terminals or connectors. These connectors are designed to provide a secure and reliable connection that will not loosen over time. If you need to splice wires, you should do so in a junction box. Junction boxes are designed to provide a safe and enclosed space for splicing wires. They are typically made of metal or plastic and have a cover to protect the splices from dirt, dust, and moisture. When splicing wires in a junction box, you should use approved connectors. These connectors are designed to provide a secure and reliable connection that will not loosen over time. You should also make sure that the splices are properly insulated. This will help to prevent electrical shock and short circuits. The National Electrical Code, or NEC, provides detailed requirements for electrical installations. The NEC is updated every 3 years to reflect changes in technology and best practices. It is important to consult the NEC before performing any electrical work. Article 312 of the NEC covers the requirements for cabinets, cutout boxes, and meter socket enclosures. This article provides requirements for the size, construction, and installation of these enclosures. Article 314 of the NEC covers the requirements for junction boxes, pull boxes, and conduit bodies. This article provides requirements for the size, construction, and installation of these boxes and bodies. Article 408 of the NEC covers the requirements for switchboards, switchgear, and panel boards. This article provides requirements for the size, construction, and installation of these devices. The NEC also provides requirements for the types of wiring methods that are permitted in different locations. Chapter 3 of the NEC covers wiring methods and materials. This chapter provides requirements for the types of cables, conduits, and other wiring methods that are permitted in different locations. The NEC also provides requirements for the overcurrent protection of electrical circuits. Article 240 of the NEC covers overcurrent protection. This article provides requirements for the types of fuses and circuit breakers that are permitted in different locations. It also provides requirements for the size of the overcurrent protection devices. The NEC also provides requirements for the grounding of electrical systems. Article 250 of the NEC covers grounding and bonding. This article provides requirements for the grounding of electrical systems to protect against electrical shock and fire hazards. When working with electricity, it is important to follow all applicable codes and regulations. This will help to ensure that the electrical installation is safe and reliable. The ampacity of a conductor is the maximum current, in amps, that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. The ampacity of a conductor is determined by several factors, including the size of the conductor, the type of insulation, the ambient temperature, and the number of conductors in a raceway or cable. The NEC provides tables that list the ampacity of conductors under different conditions. Table 310.16 of the NEC is a commonly used table for determining the ampacity of conductors. This table lists the ampacity of conductors based on their size, insulation type, and ambient temperature. The ampacity of a conductor must be sufficient to carry the load that it is intended to serve. If the ampacity of a conductor is too low, the conductor will overheat and could potentially cause a fire. It is important to select conductors that have the appropriate ampacity for the intended load. The voltage drop in a circuit is the decrease in voltage from the source to the load. Voltage drop is caused by the resistance of the conductors in the circuit. The longer the circuit, the greater the voltage drop. Excessive voltage drop can cause problems with the operation of electrical equipment. For example, lights may dim, motors may run slowly, and appliances may not operate properly. The NEC recommends that the voltage drop in a branch circuit should not exceed 3%. The voltage drop in a feeder should not exceed 5%. It is important to calculate the voltage drop in a circuit to ensure that it is within acceptable limits. There are several methods for calculating voltage drop. One common method is to use the following formula: voltage drop equals 2xkxixd/cm, where volts is the voltage drop, K is the constant for the conductor material, which is 12.9 ohms for copper and 21.2 ohms for aluminum, amps is the current in amps, distance is the one-way length of the circuit in feet, and cm is the circular mils of the conductor. The circular mils of a conductor can be found in the NEC. It is important to select conductors that are large enough to minimize voltage drop. The grounding electrode system is the connection to earth of an electrical system. The grounding electrode system is designed to provide a low impedance path for fault current to flow back to the source. This helps to protect against electrical shock and fire hazards. The grounding electrode system typically consists of a grounding electrode conductor, a grounding electrode, and the building's metal frame. The grounding electrode conductor connects the grounding electrode to the neutral busbar in the electrical panel. The grounding electrode is a metal rod, pipe, or plate that is buried in the earth. The building's metal frame can also be used as a grounding electrode. The NEC provides requirements for the grounding electrode system. Article 250 of the NEC covers grounding and bonding. It is important to install the grounding electrode system in accordance with the NEC. Bonding is the connection of all metal parts of an electrical system to create a low impedance path for fault current to flow back to the source. Bonding helps to protect against electrical shock and fire hazards. Bonding is typically accomplished by connecting all metal parts of the electrical system to the grounding electrode conductor. The NEC provides requirements for bonding. Article 250 of the NEC covers grounding and bonding. It is important to bond all metal parts of the electrical system in accordance with the NEC. Overcurrent protection devices, such as fuses and circuit breakers, are designed to protect electrical circuits from overloads and short circuits. Overloads occur when the current in a circuit exceeds the ampacity of the conductors. Short circuits occur when there is a low resistance path between two conductors. Overcurrent protection devices interrupt the flow of current when an overload or short circuit occurs. This helps to prevent damage to the electrical system and to protect against electrical shock and fire hazards. The NEC provides requirements for overcurrent protection. Article 240 of the NEC covers overcurrent protection. It is important to select overcurrent protection devices that are properly sized for the circuits that they are protecting. Arc fault circuit interrupters, or F-size, are designed to protect against arc faults. Arc faults are dangerous electrical faults that can cause fires. Arc faults occur when there is an unintended arc of electricity between two conductors. F-size detect arc faults and interrupt the flow of current. The NEC requires F-size to be installed in certain locations, such as bedrooms. Ground fault circuit interrupters, or GFCIs, are designed to protect against ground faults. Ground faults occur when there is a path for current to flow to ground. GFCIs detect ground faults and interrupt the flow of current. The NEC requires GFCIs to be installed in certain locations, such as bathrooms, kitchens, and outdoor areas. Electrical panels should be inspected regularly to ensure that they are in good condition. The electrical panels should be free of dust, dirt, and moisture. The circuit breakers should be properly labeled and in good working order. The wiring should be in good condition and properly connected. If any problems are found, they should be corrected immediately. Electrical panels should be installed in a location that is accessible and well ventilated. The electrical panel should not be installed in a location that is exposed to moisture or extreme temperatures. The electrical panel should be properly grounded and bonded. The electrical panel should be protected from physical damage. Electrical work should only be performed by qualified individuals. If you are not qualified to perform electrical work, it is important to hire a qualified electrician. A qualified electrician has the training and experience necessary to perform electrical work safely and in compliance with the electrical code. When working with electricity, it is important to take precautions to protect yourself from electrical shock. Always turn off the power to the circuit before working on it. Use insulated tools and wear rubber gloves and shoes. Never work on electrical equipment in wet conditions. If you are not sure how to work safely with electricity, it is important to consult with a qualified electrician. Always disconnect the power supply before working on electrical equipment. Never work on electrical equipment in wet conditions. Use insulated tools and wear rubber gloves and shoes when working on electrical equipment. Be aware of the location of overhead power lines and underground utilities. Call before you dig to avoid damaging underground utilities. Follow all applicable codes and regulations when performing electrical work. If you are not qualified to perform electrical work, hire a qualified electrician. When working with electricity, always err on the side of caution. If you are not sure how to do something safely, do not do it. Consult with a qualified electrician. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work. Electrical work is dangerous and should only be performed by qualified individuals. The NEC is a comprehensive document that provides detailed requirements for electrical installations. It is important to consult the NEC before performing any electrical work. The NEC is updated every 3 years to reflect changes in technology and best practices. It is important to stay up to date on the latest edition of the NEC. The NEC is available for purchase from the National Fire Protection Association. The NEC is also available online. Electrical safety is everyone's responsibility. By following safe practices, you can help to prevent electrical accidents. Be aware of the hazards of electricity and take precautions to protect yourself and others. Report any electrical hazards to the appropriate authorities. Electrical safety is a shared responsibility. By working together, we can help to create a safer environment for everyone.